we'll go ahead and start creating some actual element type properties. We have the option here to be able to create different types of plate, beams, rods, springs, and layouts. But we'll start off with the plates, probably the simplest one here. By default, we just have a standard default name and ID number, or ID number 1. For just standard steel plate, we don't have to concern ourselves with failure theory or anything. This is for for laminate plates. You can have multiple layers in your plating definition. Typically, that's not something that we use, but you can have multiple layers if you were creating, say, composites. For a standard steel plate, you just got one layer, and what we'll do is create a new plate type. And whenever you click the ID in the plate type, and this is something that'll also occur for beams and other things, it asks if you want to copy an existing one or create an entirely new one from scratch. If you copy an existing one, you can click on one of the ones that's already in there, and it will pre-populate the new dialog with all of those values, and you just change the name, and then you can make any adjustments. If you say no, it'll bring up just a blank field here, right? You have to fill everything in. So if we call this 5mm AH36, if you right click on the layer here, you can add a layer. And for steel, we would typically only have one layer, but as I said, you can have more than one. And I'll just remove that one and put a single layer of steel here. Now we don't want ST24, we want this to be the AH36, so we simply click on the material type and change it. Our thickness, which our units are currently meters, so we'll put in 005, and orientation won't matter here. And now we just say create, and it adds it to our plate list at the bottom here. Now this dialog can be resized so we can see if there are more of them here, but that's a little labor intensive. So an easier way of doing it is to simply click on the library button, and you have available predefined here 4 to 33mm plate, or if you want to work in SI, or you can use the IPS names. And we can also select which material we want to create these plates from. So if I already created a 5mm plate here, which if we want, I can go in here and delete it. So that plate that we just created is gone. But we come into the library and I can say I want to make a 5mm plate, but I forgot to change the material type here. So let me remove that from my list. I haven't committed anything yet because I haven't hit OK. So you can add and remove from the list that you want to add to the model here until you have everything that you want. But I'm going to change this to AH36 and add some 5mm plate, say some 8mm and some 12mm. And then you can change to a different material type and add some 5mm HSLA 65 as well if we want. And this can be, just any collection of plates you want. We just want to have a couple available for when we build our beam, we can assign them differently just to see some differences. And when you hit OK, they all get added to your plate list. And you'll see we now have various names available for each one. There's a corresponding ID number. You can move back and forth between which one is selected using either one of the drop lists. It'll get you to the same material type, or you can simply double click on an item in the list and it'll change the current one to the one you clicked on, as well as bring up the properties. If we wanted to change something, when it's the active property up here, you can simply go into the dialog and change the value. If you either entered something incorrectly or wanted to change it later, we can make that 5.5mm plate if we want. Now that won't change until you hit the modify button. And there are two separate buttons here depending on whether you are creating a new material or modifying an existing one. So if you're creating a new one, you want to hit the create button. If you're changing an existing value, after you make the changes, hit modify. If I were to change that value and add, say, a 6 on the end, and I don't hit the modify button, if I change to a different material and go back to it, that change was lost. So after you make some changes, and that's especially important if you create a new material based off of an existing one. So I say, yes, I want to copy an existing property, and I'm going to copy the 8mm plate, and I'm going to call this new one 8mm, and I'm going to make it out of HS65. Now it copied the original 8mm AH36. I haven't changed anything, so it's basically the exact same material with a different name right now. I would need to come in here, change the material type, and then modify it. And if you leave this dialog before you hit that modify button, you'll wind up with two materials that are identical with different names. So that's one thing to be careful of. Similarly for beams, we have the option to create a number of different beam types, T's, bars, bulb flats, angles, tubes, boxes, and this I1. Now, there's a description of what each one of these is, along with diagrams of what the various parameters are in the help manual, as well as the PDF version of it. One thing to be aware of is that for the dimensions of a T, when you define the web height, web thickness, flange width, and flange thickness, the web height is from the base of the web up to the bottom of the flange. It's not the overall height of the stiffener, it's only the height of the web portion of it. So if you're given the overall total height, you'll want to subtract off the flange thickness when you're defining your web height. So we can, as we did with the plate, you've got the same options here where you can define a user-defined name, and then there's also the associated ID number. To create a new one, you simply click on the ID number, or you click on the ID button, and it'll ask whether or not you want to copy an existing one or just create it from scratch. I'm going to say no, but we also have the library button here. And when you click on the library button, it'll ask you to load the AISC shapes database. And this is the CSV, just the comma separated value version of the AISC shapes database. It's included in the Maestro installation. So you can simply, if it's not already there, you can navigate to the C drive, program files, Maestro system, and you should have the AISC shapes database there. And you simply open it, and similar to the plate dialog, and resize this to make it a little easier to see everything. You can display the data using the SI name or the IPS name and select what material you want these to be made out of. So we can just grab a few from this listing in here, and we'll grab some WT shapes in here. We'll get some fairly small ones. We'll add a 75, 100, and we'll grab a 125 in here. Now I made these out of ST24. I meant to do those out of AH36. So I'm going to grab these and remove them, switch my material, and then add those back in. And I'm not sure if double-clicking, no, double-clicking doesn't bring it over. You have to hit the move button there. But now they're all AH36, and I'll just say OK, and we have several in here. Now, if you have, say, a built-up section, and you can use whatever naming convention you want. By default, when you bring them in from the library, you get the shape name, and in this case, the WT 75 by 6 or by 6.5, and AH36 in parentheses to let you know what the material type was. When we create our own built-up sections for, say, a large frame or a girder, we'll typically use the precursor with BU for built-up. So if we create a new one here, and we'll go ahead and copy this 75. And by default, when Maestro has a duplicate name, it'll add a plus onto the end. And if there was already one with a plus, it'll add an additional one. So you'll see when you're importing things from, say, the export scripts in Rhino, it creates sample names for properties just as a temporary assignment. Like when you bring in beams, it needs to assign some property to that beam. So we create a default name called sample, which doesn't, it has a, a null property to it, but it does have a, a nominal 5-inch height, so you can see it in the model. But they're all named the same, so that when it comes in, you'll wind up with sample, sample plus, and so forth. Now, those can all be purged once they're no longer in use in the model, as well as consolidated. There's a feature in Maestro, and we can do some of these examples when we pull up one of the sample hulls. We'll go through and use some of these features to clean up the material list, because on a large vessel, the number of beams used can get quite extensive depending on how detailed your model gets. But we'll go ahead and change this name and we'll call it built up, and we'll make it 200 by 8 by 10. And each 36, let's use that material type. I didn't change any of these values in here, so I'll need to manually go in, put in 0.2. And if you hit the tab button, you can cycle between fields fairly quickly with the tab button, so you don't have to keep going back to the mouse. But we'll have the web thickness of millimeters, flange width of 150, and a thickness 10. And, this one won't be a stiffener. Let's say we use this one as a girder. Now, this definition for stiffener, frame, or girder is for when Maestro goes to search for those evaluation patches. Maestro will go through and search the model for basically the boundaries of a stiffened plate. Likewise, when it's looking at a beam to find the supported length for that beam, or I guess unsupported length rather, it'll search until it finds either, it's attached to a bulkhead, it's supported by a stanchion, or if it's a frame, if it's hits a girder, that basically defines the end of that beam. Well, that's why we need to know whether it's a stiffener, a frame, or a girder, because there is a hierarchy in that search algorithm, so that a stiffener can be broken by a frame or a girder or bulkhead or stanchion. A frame will not get broken by a stiffener. It'll keep searching to find its next support point, but it can be broken by a girder, a stanchion, or a bulkhead. And a girder will not be supported by a frame. It'll go to either bulkhead or stanchion. So that's why you'll want to define whether it's a stiffener, frame, or girder in here. So you may have several materials, especially with these built-ups. You may have the same built-up that's used as a frame in some places and as a girder in others, and so forth. Additionally, there's the material cost and labor cost you can define in here if you want. Usually we skip those. The name check is just a quick check on any of the defined beams that you've created. Now, I made these changes here, but I haven't hit the modify button. So you'll see the values associated with my built-up are still those originals from the WT75. When I hit modify, now they get changed. Had I left this dialog and forgot to do that, I would have had a name that had the wrong values associated with it. And I'm going to change one of those right now. Well, let's run the name check first. And if we look down in the output window, it's giving me a warning saying, please review this property. The name says it's 200 by 8 plus 150 by 10, but the actual values are 200 by 8, 150,000 by 10, and that's because I forgot the decimal place there. That is, the flange width is 150 meters wide, which is obviously wrong. So I come in here, I add my decimal point and say modify. And now if I tell it to check names, I thought it would have passed that time. But that's what the check names feature is supposed to do. It compares the definition or what you've called the beam. It looks for numbers in here. And specifically in this format with the height and thickness of the web, and then the flange width and thickness, and compares it to the values used to define it, just as a quick check, and it'll flag things that you may want to review. Now, in this case, it's now correct, so we don't have to worry about it, but it's just a little safety check. You can also reorder the beams up and down. There is an option for, well, this will query what the inertias are of that particular section. And you also get a measure of the weight per meter at the end here. Usually the dialog isn't quite that wide though, and you wind up not seeing that. And actually, for purposes of making this beam model, let's also add some flat bar in here. So we'll create, I like to use FB, and we'll call it 75 by 5. 36. I hadn't hit the ID button to create a new one yet, so the name that I typed in got lost. And because it's flat bar, it's going to ignore those flanges, but we'll make it and it should ignore those others and make them 0. Did something wrong there, I think. Oh, I hit modify. I should have hit create. I'm making something new, so I'm creating it. If I had copied it from an existing property, it gets created as soon as you hit that OK button when you gave it a name, and it would have been added to the list, and that's when you have to hit modify. Since I told it not to copy, it created a new one, and it's not going to create it until I hit the create button. I lost the changes that I put in because I hit the modify button when I was creating a new material. So it's something that you'll get used to. Usually you'll do a copy and modify. Once you've started and have a few things defined, it's much easier to copy and modify. And that applies also to when we're working with the model. For rods, you'd create them the same way. You click the ID button to create a new one. You get very similar questions asked when you go to create these. Now, this is a fairly new dialogue. I actually haven't used this before, the mooring aspect of it. Previously, this dialogue, and I think if you look in the help, it's only going to talk about rods, not mooring lines. But more commonly, you may have some springs or stiffener layouts if you're doing the coarse mesh models. For stiffener layouts, there is a naming convention that we typically use in the Maestro models where it indicates what the number of internal stiffeners is, and then whether or not you have a stiffener on the first edge, second edge, or both. When you go to create these, they're typically named with the beam that you're using, and in this case, we'll use flat bar 75, so we'll call this B75 5 parentheses 2 plus, and give it a 1, so that what we're going to do is have 2 internal stiffeners and edge 1. If this was 2 plus 2, it would be 2 internal and 1, and the second edge is stiffened. And if we made it 2 plus 3, it would be both edges stiffened. We'll go ahead and create that. Oh, oops, hit it twice. The other option for number of internal stiffeners is also breadth between stiffeners. And had we defined that instead, and let's say we use half a meter, modify it, you'll see it changes how it's defined from number of internal stiffeners to breadth between stiffeners. And for that one, you would give the spacing and whether or not there's an edge stiffener. But that's basically how we create all of these various properties. Also, there is a button here specifically for stiffener layout. And I think if you look in the help manual, the layout tab is not there. The original properties manual only had these first 4. and the layouts were done separately in this dialog. But as you can see, it's extremely similar to the upper portion of the tab in the properties. And the properties tab is the easier place to do it because you can see all of the existing ones, which may make it a little easier when you're creating a new one and copying from an existing. But it essentially does the exact same thing, whether you're using this dialog or the other dialog.